Hi. So we have learned about the overview of photosynthesis and also the absorption spectrum of the photosynthetic pigments. Now we are going to learn about light-dependent reaction. The learning outcomes for this subtopic is for students to be able to explain the cyclic and non-cyclic photophosphorylation. This is where photosynthesis occurs in the chloroplast. There are two reactions involved in photosynthesis, which is the light-dependent reaction, occurs at the thylakoid membrane, and also the light-independent reaction, occurs in the stroma. For light-dependent reaction, the pigments on the thylakoid membrane absorb the light energy, the photon, and uses H2O to produce ATP and NADPH, also oxygen as the byproduct. Light-dependent reaction occur in thylakoid membrane. Remember that it requires light energy in the form of photon, light energy also known as photon. The photon is then absorbed by the photosynthetic pigment, which will be converted to chemical energy in the form of ATP and an ADPH molecule. An ADPH is an electron carrier. There are two types of light-dependent reaction. There will be non-cyclic electron flow. Non-cyclic means it does not use the same molecules that when it starts. And then we have the cyclic electron flow, means that it uses back the substance, the molecule, when it starts. Okay. So for non-cyclic electron flow, we are talking about the electron. Electron flow, non-cyclic electron flow involve both photosystem 1 and photosystem 2. While for cyclic electron flow, it involves only photosystem 1. There are a few stages in the light-dependent reaction. Photoactivation. We need to know what does it mean. What is the meaning of photoactivation? It occurs when the accessory pigments absorb and pass the photon to the primary pigment in the reaction center. So the electron in the primary pigment will be raised to a higher energy level, meaning that it gets energy from the photon. So once the electron have enough energy, it will be excited and then released to the primary electron acceptor. So the release of the electron from the reaction center will cause an electron deficiency in the photosystem. So remember the photosystem, the reaction center, the primary electron accept the primary the reaction center, the primary pigment. This is the primary pigment and this is the primary electron acceptor. So electron from the primary pigment will be excited and released to the primary electron acceptor. So this primary pigment will has deficiency of electron. It loses electron, right? So electron from primary pigment released to the reaction to the primary electron acceptor. So it loses an electron. So the imbalance of the electron deficiency should be replaced. Okay, should be replaced. So how and where can we get another electron to replace the loss of the electron in the primary pigment? So this is where water is important. So water that is absorbed into the chloroplast will be lysed. during process of photolysis. Okay. Photolysis of water is a process of splitting of water molecule by photon. Okay, photon is the energy, so energy is enough to split the water. Photolysis of water occurs in the non-cyclic photophosphorylation. Okay, it does not happen in the cyclic. It only occurs in the non-cyclic photophosphorylation. So the electron lost from the photosystem or the primary pigments, it can be either replaced by the electron from the photolysis, or it might come back. The electron will be cycled back to where it comes from. Right. So for photolysis of water, the electron that generated from the photolysis of water will be used to replace the loss of electron in the photosystem 2. Okay. Jadi, so let's see the equation that split the water. So we have the oxygen, we have the hydrogen ion, the proton, and then the electron. So electron will be replacing the loss of electron in the primary pigment. So oxygen combined with another oxygen forming oxygen gas. Then it will be released into the air. This will be replaced, while proton will be released into the thylakoid space. Remember, thylakoid, the membrane, and then this is the lumen. So this is the space. Another stage that we need to understand is photophosphorylation. So we have come across this term before in the cellular respiration. So it is a process that synthesizes ATP. The synthesis of ATP is coupled to the transport of electrons that have been excited by photon or light energy. Excited ni elektron yang daripada reaction center tadi. The electron that comes from the primary pigment. There are two types of photophosphorylation: non-cyclic and cyclic photophosphorylation. So for non-cyclic photophosphorylation involve the non-cyclic electron flow. Yang tadi yang kita mula belajar tentang electron flow. So for non-cyclic electron flow, it will involve both PS1 and PS2, P700 and P680. While cyclic photophosphorylation only involves cyclic electron flow, and which involve PS1 only. This is the whole schematic diagram of light-dependent reaction. Okay, since this diagram shows involvement of photosystem 2 and photosystem 1, so we can conclude that this is a non-cyclic photophosphorylation or non-cyclic electron flow. If you were to explain this diagram, let's see that the photon is absorbed by the accessory pigments, and then the energy is transferred to the reaction center. Since the P680 received the energy from the photon, the energy will excite the electron from the primary pigment to the primary electron acceptor. Right. This creates an electron deficiency in the P680. So the electron deficiency will be replaced by the electron from photolysis of water. So this is a photolysis of water. What happened here just now is the photoactivation. So electron will flow from primary electron acceptor through electron transport chain, pass down from plus to, we will learn later, okay, the chain, and towards the P700. Okay, before, while P680 is exciting an electron, exciting electron from the reaction from the primary pigment, P700 also receive the electron, the energy from the photon, which is absorbed by the accessory pigments, and also will excite electron to the primary electron acceptor. So every time it involves 2 electrons. The loss of the electron from the P700 will be replaced by the electron from the P680 from PS2. Okay, so electron from PS2 will replace the loss of electrons in P700, PS1. Electron from the P700 will be received by the primary electron acceptor and then will be passed through the ETC and will be received by NADP+. Okay, this is the enzyme. This is the enzyme that will catalyze the transfer of the electron to the NADP+, and at the same time NADP+ will receive a proton and form NADPH. During the flow of the electron through the electron transport chain, we can see that there is a photophosphorylation occurs that produce ATP. Okay. This is a cyclic photophosphorylation that involves only PS1. So it involves cyclic electron flow. As usual, the same as before, photon is absorbed by the accessory pigment and then transferred to the reaction center. The primary pigment will receive the photon and excite electron towards primary electron acceptor. The primary electron acceptor will transfer the electron through to the ferredoxin, and then the electron will pass through the ETC and back to the reaction center, to the photosystem. So the flow of electron here is enough for photoactivation to photophosphorylation to occur. So this will produce ATP. Ada nampak beza tak antara cyclic photophosphorylation dengan non-cyclic photophosphorylation? So non-cyclic photophosphorylation involve PS1 and PS2. It produces ATP and NADPH. Involve photolysis of water. The same things is both involve the cyclic and non-cyclic involve photoactivation and photophosphorylation, but in cyclic there will be no photolysis of water and production of NADPH. Jadi kalau cyclic, here it starts here, so more ATP will be produced. Right, let's look at again the description, because just now I explained through diagram. Okay, in non-cyclic photophosphorylation, the first step is the absorption of the photon by accessory pigments of PS2. So we start with PS2. Then the photon is transferred from one accessory pigment to another until it reaches the primary pigment in the reaction center of PS2. Then the P680 undergo photoactivation. So use the term correctly, undergo photoactivation, meaning that the electron is excited from the primary pigment. The electron in P680 is raised to a higher energy level and becomes photoexcited. The photoexcited electron passes to the primary electron acceptor and creates electron deficiency in PS2 because it lost electron. Next, photolysis of water will replace the loss of excited electron in the P680. by splitting water into hydrogen, proton, and oxygen, and electron. So you need to remember the equation. So P680 will return to its reduced state because it received the replacement electron. Okay, next, the oxygen atom will combine with another oxygen atom and then release into air in the form of oxygen gas. The proton will be released into the thylakoid space. Next, the photoexcited electron here, the electron here received by the primary electron acceptor will be passed to the through an electron transport chain that composed of made up of +2 quinone, PQ, here is the +2 quinone, then cytochrome complex and +2 cyanine here. 1, 2, 3 components of electron transport chain. So the transfer of the electron through the ETC will provide energy to synthesize ATP from ADP and phosphate inorganic. So this is what we call as photophosphorylation. Right, this is a real diagram, this is an illustration of the ETC, components of ETC that helps in the transfer of electron and thus involved in the photophosphorylation. Okay, while the electron is being transferred from through the series of electron transport chain, the hydrogen ion will be pumped. It will be pumped and involved in the chemiosmosis, similar to what happens in the electron transport chain. Okay, so the photophosphorylation occurs. The photophosphorylation occurs because the proton are pumped to the thylakoid space, to contribute to the proton gradient that will be important, useful for the chemiosmosis then to create to produce ATP for during photophosphorylation. Okay, next, at the same time, a photon of light is absorbed by accessory pigments of PS1. So remember, the light energy absorption occurs simultaneously in P700 and P680, PS1 and PS2. So the same thing happened to what happened in PS2 also occurs in P700, the photoactivation. So electron from the P700 will be excited to the primary electron acceptor. Okay, then the electron from the P700 will have electron deficiency. So the electron from the PS2 will replace the electron loss in the P700. Okay. The photoexcited electrons that are passed from the primary pigment to the primary electron acceptor will be passed through the electron transport chain. So the ETC here is slightly different from the ETC in between PS2 and PS1. Yang tadi ada PQ plus 2 quinone, ada cytochrome complex, and then we have the plus 2 cyanine. But for this series, for this chain, the series involve ferredoxin and an ADP plus reductase. Okay, the chains involve the ferredoxin, and the enzyme here will be the last. Will be catalyzing reducing of NADP+. Right, the NADP+ reductase catalyzes the transfer of electrons from the ferredoxin here to the NADP+. So NADP+ will be reduced as it receives the electron from the paradoxin and proton. Reduced to NADPH plus H+. The proton comes from the thylakoid space. So the product of non-cyclic photophosphorylation is NADPH and ATP. This will be used in the Kelvin cycle. Cyclic photophosphorylation. In cyclic photophosphorylation, the PS photosystem that is involved is only PS1. So mention photosystem 1. A photon of light is absorbed by accessory pigments of photosystem 1. Tak boleh sebut photosystem saja. We have to mention photosystem 1. Then the photon is transferred from one accessory pigment to another until it reaches the primary pigment. So primary pigment will the electron in the primary pigment will raise up to a higher level of energy, which will be photoexcited. Okay, the electron will be excited to the primary electron acceptor and creates electron deficiency in P700. The primary electron acceptor will pass the electron through a series of electron transport chain that consists of ferredoxin, cytochrome complex and plastocyanin. Includes ada ni sekali, tadi tertinggal. Ini cyclic, sorry, tadi tu non-cyclic. So in cyclic ada ferredoxin, ada cytochrome complex dan juga PC, plastocyanin. So this creates energy. This creates photophosphorylation. Creates energy that helps in photophosphorylation. The transfer of electron through ETC provides energy for the synthesis of ATP. Electrons from the plastocyanin will return to the PS1. So P700 will return to its reduced state. And the product will be the ATP. And then used in Kelvin cycle, which is the light independent reaction. Kalau dalam non-cyclic tadi, primary electron acceptor dekat ujung tu dia akan pass kepada ferredoxin, kemudian pass kepada NADP+ reductase kan. To the NADP+, which is catalyzed by the NADP+ reductase. Tapi bagi cyclic photophosphorylation, ferredoxin, cytochrome complex and then plastocyanin back to P700. Situ dia punya beza. Thank you.